Dear students, let's see this question. In the figure shown, a plank of mass m is lying at rest on a smooth horizontal surface. So here a plank is there. A plank. On this plank, a plank of mass m is lying at rest on a smooth horizontal surface. Here surface is there. So it is smooth surface. Surface is smooth. And if you see here, a disc of same mass, let m be the mass of the plank, m be the mass of the plank, and a disc is there, and disc mass also m, and radius r is given. And here it is rotated to an angular speed omega naught. So initially it is rotating with an angular speed omega naught, and it is gently placed on the smooth surface. Sorry, gently placed on this plank. See here, and then gently placed on plank, it is found that finally slipping ceases. For example, at this point, slipping ceases. We know slipping ceases means there is no slipping conditions. So at the time of slipping, or at the time of slipping ceases, we know V is equal to R omega condition. V is equal to R omega and A is equal to R alpha. Clear? And he's saying that 50% of the total kinetic energy of the system is lost. Assume that the plank is long enough and mu is coefficient of friction between the disc and the plank. So he's asking 4 questions are there. Based on this concept, how many questions are there? 4 questions are there. He's asking 4. So we'll try to solve one by one. So first question what he's asking is, he's asking that time when slipping ceases. Time when slipping ceases. We'll try to understand. So in this situation here, it is rotated. Initially, the disc is rotated through an angular speed omega naught, and it is gently placed. If it is gently placed, at the time of contact here, if you observe the direction of frictional force, we'll try to understand. See, the disc is rotating in this direction. Disc is rotating in this direction. If the disc is rotating in this direction, so at this point the frictional force will be in this direction. Frictional force. Clear? I hope you understood, right? Disc is rotating in this direction. At this point, the particle velocity will be in this direction. So friction will be here. So again, on this plank, on the disc the friction is here. On this plank, the friction force will be here. So for the two bodies, the driving force is frictional force only. There is no external force. For the two disc and the plank, the driving force is only the frictional force. Now we see how to solve. And again he is saying that at this point, slipping ceases. We'll try to understand. For example, I am writing here for a disc. See, whenever we are doing questions based on rotational motion, so we have to go simultaneously. Many times I will say the word go simultaneously. We have to go simultaneously. Simultaneously means both translational and rotational. Translational you have to get the equations, and rotational also you have to get the equations, right? Now we will see for the disc I will write the translational. So here the driving force is F. So F is equal to ma. F is equal to ma. So here we know that. So we know that F is nothing but mu mg. F is equal to mu m. So F is equal to mu mg. So I will write here mu mg, which is equal to ma. So m get cancelled. So A is equal to mu g. So acceleration of disc is mu g. Acceleration of disc is mu g. At the same time for the plank. See. For the plank also, driving force is F only. Driving force is F only. So I will write F is equal to ma. So both masses are same. M is given. So F is again mu mg. Mu mg is equal to ma. So again m get cancelled. So here mu g is equal to A. So if you see for both disc and plank, the acceleration is mu g only. And again, initially there is no linear velocities. Initially there is no translational velocity. So initial velocity for both disk and plank is 0. So here u is equal to 0. Here also u is equal to 0. So we'll try to find out the velocity at the slipping CGs. So v is equal to u plus at. So u is equal to 0. So velocity of disk Vd is equal to how much it is? A value is mu g into t. In the similar manner, v is equal to u plus at, u is equal to 0. So velocity of plank is equal to what is A? A is mu gt. So these two are important points. I will write here. Velocity of plank is equal to mu gt and velocity of disk is equal to mu gt. I hope you understood, right? Clear? And one more thing, try to understand. So at this point, the disk will move in this direction, velocity of disk, and the plank will move in this direction, velocity of plank. So under the condition of slipping seizures, at this point, if you see, the velocity will be, we know that in case of no slipping, formula generally v is equal to r omega. V is equal to r omega. So what is v here? V. So this one is moving in this direction, particle is moving in this direction, and plank is also moving in this direction. So the net velocity will be the total velocity. So Vp plus Vd is equal to r omega. Vp plus Vd is equal to r omega. So we got Vp and Vd value we got here. So mu gt plus mu gt is equal to r omega. So here 2 mu gt is equal to r omega. So omega is equal to 2 mu gt by r. Clear? I got omega value. Omega at what point? At the slipping CGs. At the point of slipping CGs, the omega value is how much it is? Omega is equal to 2 mu gt by r. I hope you understood, right? So now we are going to calculate the time we have to calculate. Further time what we will do is, this is translational. So I will write the equation for the rotational, and after we will try to understand, right? See, we got velocity of plank, velocity of disk, and omega. At that instant t, it is 2 mu gt by r. Now we will see rotational. So here, torque due to force. So force into perpendicular distance, which is equal to I alpha. Correct? Torque V is equal to I alpha. Torque V is equal to I alpha. Here torque is nothing but force into perpendicular distance. Here force is frictional force. So I will write frictional force into R is equal to I alpha. From that, F R is equal to I. What is I? Moment of inertia. Moment of inertia with disk is mr square by 2. Mr square by 2, which is equal to alpha. So here R will cancel. So F is equal to mr by 2 into alpha. So we know F is equal to mu mg, which is equal to mr square r square by 2 into alpha. This one is small m only. So get cancel. So mu g is equal to r square by 2 into alpha. So alpha is equal to 2 mu g by r square. Alpha is equal to 2 mu g by r square, right? So I got angular acceleration also. So I will write here alpha is equal to 2 mu g by here it is mr square by 2, right? 1r it cancel, here r is there. So by mistake I wrote here r square. Just try to understand, here r will be there. So here it is mu g, alpha is equal to 2 mu g by r. So 2 mu g by r. Am I clear? But now actually what he is asking? He is asking the time when the slipping ceases. Time we have to calculate. So we will see how to calculate the time. So we know that when disk is rolling, initial angular velocity is given as omega naught, and after time t it becomes omega. So in what time it becomes omega? We know how to calculate. The formula v is equal to u plus at. So omega 2 is equal to omega 1 minus alpha t. Correct? Here friction is opposing the motion, right? That's why I wrote minus alpha t. Here alpha is nothing but retardation, not acceleration, right? Angular retardation we are saying. So here omega 2 is omega, which is equal to omega 1 is given as omega naught minus alpha we got 2 mu g by r into t. So what we have to calculate? Clear? So omega value is also given there. So omega value also we got how much it is? 2 mu g t by r, which is equal to omega naught minus 2 mu g t by r. So this is minus, I will send here. So omega naught is equal to 2 mu g t by r plus 2 mu g t by r, which is equal to 4 mu g t by r. So I got here omega naught can written as omega naught is equal to 4 mu g t by r. How much omega naught? Omega naught is equal to 4 mu g t by r. This one also I will keep it in mind. Clear? We have to keep it in our mind. And from that he is asking t value. So t is equal to how much we will get? Omega naught r by 4 mu g. T is equal to omega naught r by 4 mu g. So this is what he is asking. He is asking the time when sleeping ceases. So at this time, within this time, the body comes under no sleeping conditions. So I think this will be the right answer, right? So here I will write T also, but because again 3 more questions are there, so we have to save, right? So T is equal to omega naught r by 4 mu g. Clear? Am I clear? I hope you understood, right? So we'll go with the next question. See, second question what he is asking? He is asking that find final velocity of a Planck. So velocity of Planck is asking. So Planck means directly it is translation only. So directly we will go with the translational motion. So initial velocity u is equal to 0, and we got velocity of Planck. How much we got? Vp is equal to mu gt. Vp is equal to mu gt. So t already we calculated omega naught r by 4 mu g. So velocity of Planck is equal to mu g into t value. So omega naught r by 4 mu g. So mu g get cancelled. So velocity of Planck is equal to omega naught r by 4. Velocity of Planck is equal to omega naught r by 4. See, easy question only, right? Try to understand the concept. If you understood the concept, it will be easy to solve. Clear? We will go with the next question. See, distance moved by the Planck within the time. So in that time, how much distance the Planck will move? Again, this one will come under translation only. Directly we can apply. But here it is accelerated, right? So Planck is accelerated. So I have to use S is equal to ut plus half a t square formula. So here S is equal to ut plus half a t square. So initially Planck is at rest. So u is 0. So S is equal to half. What is a? Acceleration of Planck. Already we calculated, right? Again we will try. So F is equal to ma. So F is nothing but mu mg, which is equal to ma. So get cancelled. So A is equal to mu g. So acceleration of Planck is mu into g. So I will write here half mu into g, and t already we calculated. T omega naught r by 4 mu g. Omega naught r by 4 mu g, but here this square. So square that one. So omega naught square r square by 4 mu g square. So 16 mu square g square. So here 1 mu g and here 1 mu g get cancelled. So remaining thing will be here. S is equal to omega naught square r square by 32 mu g. Omega naught square r square by 32 mu g. So in this way we can able to calculate easily. Clear? We will see one more question based on the same concept only. The fourth question we will see. See this question. He is asking that magnitude of change in angular momentum of the disk. Magnitude of change in angular momentum. So what is the formula for angular momentum? Angular momentum is denoted by L. L is equal to I omega. So he is asking change in angular momentum. So here change in angular momentum. Change in angular momentum. Angular momentum is denoted by L. Angular momentum is denoted by L. Change in angular momentum I will write delta L. Delta L is equal to LF minus LI. So L, angular momentum formula, L is equal to I omega. So I omega final minus I omega initial. So anyway, moment of inertia is remains same, disk, right? But omega is changed. So we'll substitute and we'll find out the values here. So now here I omega minus I omega naught. So here I will write I into omega minus omega naught. But here we know omega and omega naught also. But here omega is given in terms of 2 mu gt by r. So I want to find out omega, final omega in terms of initial omega. How to calculate? We know that V is equal to U plus AT, na? V is equal to U plus AT. So apply for angular. So here it is omega is equal to omega naught minus alpha t. Here acceleration, here angular acceleration. It is opposite. The friction is opposite, right? That's why I'm writing this minus alpha and time t. So here omega is equal to omega naught minus alpha t. Alpha is nothing but alpha we got 2 mu g by r into t. T is nothing but omega r by 4 mu g. T is there here. T is there and alpha is there. I substituted. So here omega can written as see here omega naught minus mu g by mu g and mu g get cancelled. So 2 2s are 4 and r get cancelled. This one by 2. So how much will you get? Here it is omega naught by 2 will be there. So here omega can be written as omega naught by 2. So initially it is omega naught and final angular velocity is omega naught by 2. So we write here I is nothing but moment of inertia. Moment of inertia for disk is mr square by 2. So I will write m r square by 2 into omega by omega naught by 2 minus omega naught, right? So he's asking change in. So here we get negative value, but I will find out the magnitude, right? So delta L magnitude. If you find the magnitude of delta L is written as m r square by 2 into omega naught by 2. Magnitude I'm calculating. Magnitude. Here it is omega naught minus omega naught by 2. So omega naught by 2 will be there. So omega naught by 2 I wrote here. So finally I will write here 1 by 4 m r square omega naught. This will be the answer. Clear? Important concept. Based on the concept, nearly 4 questions are there. So nice questions and try to understand. I hope you understood, right? Thank you.